Everyone, welcome to Manufacturing Hub. Grant, second episode that we've had him is getting into it. The
Mhm.
funny faces and whatnot that comes on. Very excited to go kick off Cybersecurity Month. Cybersecurity Month for Manufacturing Hub, second year in a row, is the month of October because October is Cybersecurity Month. And goodness, if we certainly don't need to talk about cybersecurity. We want to thank Phoenix Contact for coming back and sponsoring Cybersecurity Month and once again giving us grant in order to go have awesome conversations. In order to go have awesome conversations together. As everyone is getting in, I will let you know that if you want to go listen to Grant previously, he was episode 82, and we are now up to episode 137, which is absolutely crazy. If you guys are new here, welcome. If you've been here before, welcome back. If you're new here, we do our very best to go have a lively comment section. So if you're watching on LinkedIn or YouTube or Twitch or Facebook or any of these other channels, please feel free to go ahead and drop comments below. LinkedIn has been giving us a little bit of trouble. I don't know, the last week or so with some of these live events. So if we don't see, oh nope, I see Zach in the comments. Thank you, Zach. This tells me that we should be able to we should be able to go see all of the comments. Thank you for that, Zach. Always here with the most perfect timing, which was probably about 5 seconds before you actually went through the process of typing that. But we do our very best to have lively comment section. Guys, please feel free to go ahead and jump in into the comments, to go ask questions, to go talk kind of amongst yourself in chat. We will do our best to go bring some comments, as we just brought Zach's comments into the show. I will also say sometimes we get super technical questions that are not the best thing answered live on air. So if we get those, we'll do our very best to come back and either Grant, myself, or Vlad go answer those, or perhaps go bring in someone who is, well, certainly smarter than Vlad and I do not want to speak for Grant, as Grant is our expert here today. So without further ado, everyone, welcome to Manufacturing Hub. This is Cybersecurity Month, episode 137. We'd like to welcome back Grant Vandebrake, previously of episode 82. Grant, welcome to the show. Thank you for being here.
Yeah, thank you guys. I'm excited to be back.
Awesome. Thank you so much for joining us again, Grant. I think it's going to be a really good conversation around cybersecurity. Before we dive into that, though, could you give us a little bit of a refresher, I want to say, on your background? And we talked a little bit off stream, some of the maybe changes or a different direction that you've taken in the last a little bit over than a year. So I want to dig into a little bit into that as well.
Yeah, for sure. So I am a senior global systems engineer at Phoenix Contact. That's a fancy way of saying I help people with networks and cybersecurity for Phoenix globally. Support a lot of different product lines over the last 10 years with Phoenix. So I've done the cybersecurity products or MGuard series. I've done our managed switches, unmanaged switches, mostly to help with application development, network design. So, when a customer needs to have a network and they want to make it secure, they hire us to do services, we do assessments, we do all those services for customers to make sure that everything gets deployed properly and securely. So that's what I had done previously. And then over the last year, we have a new product line that's coming out specified for the electric power industry. So I've been doing extensive amount of work helping evangelize that platform. So doing internal trainings, working on customer opportunities. And when it comes to the utility space, as a critical infrastructure industry, cybersecurity is extremely important. So that's always a topic of conversation when we're talking about the products that we offer. So one of the interesting parts about that product line is it's network hardware, but we also include integrations in the product line for security software. So we're trying to build a full solution for security applications and network applications for the electric utility space. So yeah, it's exciting. No 2 days are the same. Like I told you guys before we hopped on, it's busy.
And we'll certainly dig into that a little bit more because again, I guess I've studied, power engineering and I've certainly not gone down the rabbit hole of, power and renewable energy systems, but it's very interesting to have gotten the insight from you again, off stream that there is a very specific set of standards that apply to networks within those industries.
Mm-hmm.
But before we get maybe into that conversation, Grant, can I ask you, I guess, how did you how did you progress into networking and cybersecurity? Because I think a lot of people don't necessarily know that it is a career path for someone who's studied, let's say, electrical engineering. And maybe also
Mhm.
to follow on onto that question, like, would you do something differently? Would you get a certain certification? Kind of like, what would you recommend someone who's looking into networking and cybersecurity today?
Yeah, yeah, no, it's a great question. So my college degree and background is actually electrical engineering. So I got an electrical engineering degree at a school. I started with Phoenix as a controls engineer. So I did PLC programming, a lot of SCADA work. We did a lot with the water wastewater industry using protocols like Modbus and DMP3, which are fairly common in a lot of the different industries in the US. So, that was my passion, doing a lot of projects involved in remote access. And over time, we started seeing that, oh, there's a need for securing these remote connections. And at the time, I had a colleague that worked with us by the name of Tom Van Norman, which he was a big influence in my career. He was sort of our cybersecurity expert. And he was like, hey, we're getting more and more projects to do this remote connectivity through VPN tunnels and using our MGuard product line. Why don't you get trained up on some of the particulars involved with security and networking? That way we can have more coverage on the projects. And so that's when I went out and I got a CCNA certification. So I went out and did the Cisco certs, which honestly, the Cisco certifications are a good start. I would also say CompTIA and the Network Plus, Security Plus, those are also great starter certifications to kind of get familiar with networking. I didn't know hardly anything about networking when I first started. I knew how to program an IEC. I knew how to find the IP address of a device, but I didn't know anything about layer 2, layer 3, what is routing, what is switching, all that stuff. And over the course of a couple of years through the CCNA certification, working on projects, setting up VPN tunnels, setting up firewalls, I started getting more familiar with that. And then through those projects, really got interested in the cybersecurity part. We had a couple of projects where we had hired like a third-party penetration testing service to just verify that web applications were secure or that these remote connections were secure, and got involved in the process with looking at how the proposal that they wrote, looking at the results that they provided us with the different vulnerabilities, and I was like, this is really cool stuff. So started diving in deeper into that, got more involved in service offerings around cybersecurity. So about 6 years into my career, 5 or 6 years into my career, we kind of realized that there was a gap to fill with security expertise and network expertise for our customers. So we started offering services to do network design and security assessments. That's when I fully dived in. And I did some more trainings. One of the other certifications I got is a GICSP, which is a certification from a group called SANS, which is a cybersecurity training organization. They're great. They have tons of trainings in different subjects. They have a whole industrial control systems track with a series of certifications there. Highly recommend some of theirs. And I will say there's plenty of resources out there. If you go Google industrial security training, there's plenty of people out there offering some good training materials. That was sort of one of the industry common ones, especially in the US. So I got that certification and then started doing the services thing. And eventually got some projects in the power industry, got experience working with power systems and substations, doing control side and the network side. And then, we had this opportunity to work with substation hardened network equipment, which was a new product offering for us. So I jumped at the opportunity, and that's what I've been doing.
Awesome. I've not heard of the CSP certification. I've heard the CISSP, which I think
Yeah.
is a bit more known in the industry. But interesting. I'll have to read up, and I'll do my best like to post the link so that people can certainly explore that a little bit more. I think like on the OT side, at least, cybersecurity, I want to say, still a somewhat nebulous topic, at least from my perspective. And I think
Mm-hmm.
not necessarily, going out and getting all these certification would be the right maybe approach, but at least having some basic familiarity with what's going on and kind of what happens, let's say, right above that firewall on the IT side, and obviously sometimes even on the OT side is important. But I guess like to follow that up with maybe like a broad and general question, right? So I think last year I've certainly heard a lot more broader stories when it came to different like breaches in cybersecurity. Have you heard of any interesting like events, like in the recent times that might be of interest, let's say, to the listeners and those who are watching to kind of investigate, hopefully within the manufacturing space, but maybe outside as well?
Yeah, so I would call 2023 and probably the end of 22 after we had our last talk, probably the year of ransomware. But that's been the most common and likely breach scenario is someone is socially engineered. They click a link. They have somebody reach out to them via direct message and follow a link that they shouldn't, and then all of a sudden there's ransomware in your IT systems, and sometimes it might find its way into the OT systems. When it comes to like specific ones, very recently there was an interesting news article about Clorox and how they had actually admitted that there would be supply chain problems and product delivery issues because of a ransomware attack that they had. So, and the thing is it didn't necessarily affect their OT systems and their operations, but it did affect their IT systems and their ability to take orders and ship based on orders. So this is the other thing that you got to take into account is, yes, we have IT and OT separated systems. You should from a good security perspective, but you also got to take into account that there are things on the IT side that govern the business that will affect how you can manage your operations on the OT side. The same with the Colonial Pipeline. So this is, I think, one that I talked about last time. The Colonial Pipeline, this actually affected the East Coast of the U.S. pretty heavily in terms of gas prices because they couldn't deliver gas to distributors and gas stations on the East Coast. That was not an OT system attack. Like it never found its way into OT systems, but it affected their ability to bill for the gas that they were putting through the pipeline. So to avoid shipping things they couldn't bill, they stopped shipping oil on the pipeline. So that is an IT-based system that then has an effect on OT and how you make money with your OT system. So you always have to take into account that there's connectivity between both sides. And if you have an attack in IT that affects the production of something and your ability to bill or order for those items, you're going to have to slow down production because you're going to lose money by shipping out stuff that you're not going to get paid for. So those are two sort of non-OT related ones. Some of the other ones that I've seen recently, Kia had come out and said that they had a hit with the ransomware attack. Not a ton of detail yet on that one, but it did affect some of their customer-facing web systems in their customer portal for the cars. And then recently there was a Johnson Controls attack, which is still, the scope is still being verified at the moment. But there is some concern with the Department of Homeland Security that with Johnson Controls, they had some floor plans because of building automation, floor plans of some government buildings that could have been compromised. That they haven't confirmed that, but that's a big worry. So in terms of OT attacks, the majority of the ones that are public are going to be ransomware, and that's just because there's a dollar value attached to it, and they report that to the FTC because there's legal ramifications, and there's also some filings that they have to put in for insurance purposes. The more focused attacks, unless we find them, and there have been some in the past. I know Dragos had published some articles on a malware that they had found in PLCs. The name of it is leaving me at the moment, but those attacks are much more harder to find, and that's why you don't see them as often, because it takes a very focused effort and somebody who's actively monitoring at such a deep level down at the communications between your PLCs to actually notice. Ransomware is like, it's a bull in a china shop. It's going out and encrypting all your systems, and then it's telling you got to pay $28 million. So you're going to know there. So really,
Right, just like as a brief follow-up, like on that same like topic, and I guess maybe to put some listeners at ease, ransomware, right? Like, so again, I don't want to go like too technical, but confirm, I guess, like maybe my understanding. It typically infects like the OS system and encrypts the files that reside on that system, right? So if I have, let's say, a Windows server that is running some of the SCADA system, if I have a computer that's running, I don't know, let's call it like Ignition or some other connector, it's probably going to be affected. But if I have a PLC, it doesn't necessarily run on OS except some Linux or, like other base systems. So it's not going to be as relevant to being like encrypted, right? Like, I guess, like, how does it, like, in a, I want to say, like, very simplistic way, could you explain us how does it like spread, and ultimately, like, what's the impact for someone on the, let's say, like, plant floor?
Yeah, so ransomware is designed to make money by attackers. So they're going to go far and wide, and it's a low-hanging fruit type attack. They're just going to find vulnerable systems that they already published vulnerabilities and exploits for those systems, and that's typically Windows-based systems, because Windows has they're the biggest install base in terms of personal computing, and mostly on the industrial floor with HMIs and PCs. So typically what they do is they'll leverage vulnerabilities in older versions of Windows, like Windows 7, Windows XP, which still are deployed in industrial systems, because the vendors that make those, the OEMs that make those machines, it's difficult to update the software as frequently as Windows is going to update their OS. And a lot of times these systems are installed for 20, 30 years on the manufacturing floor. When it works, it works. And sometimes to buy a new operating system to run that machine, you have to buy a whole new machine, and you got to have the capital expenditure to be able to buy the new machine with the new version of Windows on it. So you end up having a lot of old vulnerable machines running Windows on the manufacturing floor, and ransomware is going to leverage some vulnerabilities, typically in SMB protocol, which is file share. And what it does is it, uses vulnerabilities within the OS. It establishes a foothold on a system. It'll start encrypting those files with a key that the attacker holds, and says, I will decrypt your files and you can use the system again if you pay me money. The problem is it doesn't just stop with one system. It leverages the vulnerabilities in that file share protocol to then spread out through more and more systems. So, patching your Windows operating systems, making sure if you do have an old operating system on the floor, old version of Windows, that if you can't update it, put protections in front of it to firewalls, use some host-based monitoring if you have capabilities to monitor old OSs. That way you know what's going on and you have some protection, because it's very low-hanging fruit. If you're going to leave old systems connected on your industrial network and even worse, your IT network, you're just asking for ransomware to come through and take the system over.
Awesome. I've got 100 more questions, but Dave, what are your thoughts?
Absolutely. So anyone that follows me on LinkedIn will remember me commenting over and over again how going and talking to cybersecurity experts is absolutely the most terrifying thing we do every year, because we just scare the living crap out of everyone. And man, those future predictions are absolutely terrifying. So Vlad, I would like to thank you for just driving us immediately into that first, second, and third level of terror. We don't have to worry about first, second, and third levels of networking. We're to level 3 of absolute terror. I want to get back to some of these ransomware attacks, some of these other things. But first, I want to dive a little bit more into the energy sector that you've been working in, Grant. Again, as we had talked about, energy isn't particularly something that we've worked a lot on. From that point, can you tell us kind of how energy is different than your experience in manufacturing? And then maybe we can go compare some of those similarities and differences, please.
Yeah, absolutely. So the energy industry utilizes a lot of the same technologies in terms of Ethernet and controllers and microcontroller-based devices, right? The difference is there's sort of, it's a different process. So like when you look at manufacturing, you have robots, you have a manufacturing line, you're trying to build something that then gets put in a box and shipped out, right? You have process industry where they're doing some sort of mixture, they're mixing chemicals together, or they have a recipe-based system, kind of similar with pharmaceuticals. That's a little bit different than manufacturing. Energy, what you're delivering is electricity. And the way that they deliver electricity is a continuously on system called the electric grid. So it's never off. You're constantly providing power. Well, you have generation sources on one side, which are hydroelectric facilities, gas facilities, solar, wind, nowadays more solar and wind, generating energy, but they generate energy at a certain voltage, at a certain current level with a certain phase. It may be DC, it may be AC, but there's a standard set of AC power levels that are designed to be put on lines to then send to customers, because our homes all run on 120 volt AC, at least in the US. And so when you're talking about like a solar array, the power that comes off of solar is DC, it's not AC. So you got to put an inverter in there to then get the power on to AC, which then gets put on the grid. So the one part that the substation is responsible for, so the substations sort of are the break points within the grid. They provide the transformation of power to different parts of the grid. So when you have a generation source, so a coal plant, they're generating power. That's going to go into a substation that's usually right at the coal plant. And then they have a big transformer that's going to step that voltage up and that current up to a certain level and send it over transmission lines. Now, transmission lines are one section of the grid, and transmission lines' purpose is to transmit power long distances. That's where you see the high tension power lines with the huge, big, cable carriers. Those are transmission lines. Highest voltage, highest power levels are transmission lines. Those are the ones that are scariest, and you see the guys in helicopters fly up in metal suits to try to clean them off and stuff. So transmission lines then move power long distances to then regional grids, typically called distribution grids, which they distribute power to customers. So there's usually a substation on the transmission side that steps the voltage down. There will be a substation on the distribution side that then also can step it down or step it up depending on what the customer needs in terms of voltage level. The other part to that is the protection side. So obviously transformers and the lines are sensitive components. If you blow a transformer and you can't transform power anymore, you're going to lose a large portion of the grid that's connected to that substation. Same with the line. If you have an overcurrent on the lines, the lines start burning up and you lose lines, you have to go out and replace the lines. Or even worse, you could cause a fire, which then is the responsibility of the utility to pay out insurance for the fire that they caused. So you need to have protection mechanisms in place for overcurrent, overvoltage issues on the lines, so you don't blow transformers and you don't break the line. That's where you get big, huge breakers that can switch and protect massive current levels, massive relays that are there to open a circuit if you need to. And then all of that is then monitored by protective relays, or IEDs, they call them, is an industry term. It's an intelligent electronic device. Those devices then use monitoring components to measure the voltage level, the current level, the phase angle, just to make sure that there's no issues with the power that's going into and out of the substation. And if there is, they can trip a breaker, they can open a relay so that it doesn't blow a transformer and it doesn't destroy a power line, so that it's a shorter outage. You open the breaker, this transient dies, goes to ground, and then you close it back again and power is restored. So that's kind of the grid structure. Now, within the substations, that's where you have all of your intelligence and control, typically. So you have microcontroller-based devices called protective relays, which those are the ones that are pulling in the signals of voltage, current, and phase to make decisions on whether to trip a breaker or open a relay. Those devices are typically Ethernet-based. Legacy, a lot of them are still serial, but they're all moving to Ethernet-based communications. And that's where something called IEC 61850 comes into play, which is a standard for digital substations. And that's the big movement right now in the electric industry, is to digital substations using Ethernet and Ethernet-based protocols for communication. So yeah, I've done a lot of customer talks, did some presentations with some trade shows on 61850. There's protocols in the standard. It's a huge standard that covers the hardening of the network hardware, the structure of the network, the protocols. So there's things called goose messaging, which sounds probably totally ridiculous. There's sampled values, a protocol called MMS for SCADA-based communications. So there's a whole suite of different protocols that are totally different than, Profinet, Ethernet IP, Modbus that we're all typically used to, that all have different functions in the whole substation protection scheme. So yeah.
Interesting.
That was wrong.
No, I think that was very interesting. I wasn't personally prepared for that answer, but I feel like we all have a much better understanding on the energy side. Grant, let me go ask you kind of a follow-up question. And we talked about one of kind of the special or unique parts about energy or public utilities is the fact that it's regulated by the federal government, which is why there's so much of a push for much of these standardizations. I imagine much of this technology move, kind of a lot of these things, a lot of the cybersecurity is being pushed by federal government regulation. How have you seen or witnessed that adoption? Is it a positive thing? Is it something that you see a lot of pushback? What is kind of your experience coming from more of that manufacturing industrial sector?
Yeah, so in North America, there is a set of regulations for utilities called NERC-CIP. NERC is the North American Electric Reliability Corporation. They do their critical infrastructure protection or regulations. There's a series of different security regulations that you have to follow. And utilities are audited. A lot of it is self-audit, but they are audited on the parts of that regulation that they have to follow. And if they don't, and they have gaps, or they misrepresent what they've done, they will be fined. So there's actually monetary punishment for not following the standard. I would say it's a double-edged sword. Regulation will drive an industry to adopt things, but the problem is that when you look at at regulation versus a standard, regulation, you're forced to follow something, so you try to follow it to the letter. Is that always the most secure way to do things? Not necessarily. The context matters. So you end up doing things exactly to the letter of the law so you don't get fined, but in the context of your system, maybe it doesn't make sense to do it that way. So it will raise the floor on security in a certain industry, but you always got to be careful about over-regulation and asking too much or being too particular about how they implement security control. So it's been good for the power industry in North America. It always is a conversation topic when you talk to customers about network equipment. NERC-CIP is always one of the things that they bring up. Hey, will it help me comply with NERC-CIP? And then you go through, you say, yes, you can do this, you can do this, you can do this, which is great because then it keeps vendors on it. The only thing that I always get frustrated with is a lot of times, because of this NERC-CIP regulations and because the electric power industry is definitely one of the ones that it takes a lot of time to adopt new technology. You end up having to do the tap dance. Well, I don't want to deal with an Ethernet port because it's in NERC-CIP and I don't want to have to deal with following the regulation on that. So I'm just going to stick to serial communication. And it's like, okay, yeah, I get where you're coming from, but there's so many more advantages using Ethernet. You just need to do it responsibly, and you just need to consider the CIP standards around Ethernet and implement it properly. So sometimes it causes people to shy away from new technology because they're worried about the cybersecurity ramifications. So I'm always a proponent of, you should adopt new technology because it will help you in your business and improve efficiency. You just got to do it responsibly. So.
Grant, if I can follow up and just so I again confirm my understanding, right? So I think that you've explained the electrical side extremely well, but let's say when you're monitoring or let's say controlling some of those signals at the substation level, is the idea also to relay them between the grid so that you could sort of orchestrate the entire like balance of like the different loads? Like I guess I'm trying to understand, like, the grid is connected to the internet and that data is ultimately available at a centralized location, and hence the reason why we need like cybersecurity protection. Like, how does that work?
So I would say the grid is not connected to the internet.
Okay.
The reason why, so when you look at the grid, it is an interconnected set of different owners of sections, but they all connect together, and there's a wholesale energy market, which I am not an expert on wholesale energy and how that all works. But basically, you have operators of certain sections of the grid, and their job is to ensure that their part of the grid is supplied with power. There are transmission entities, there's distribution entities. Some big utilities own the transmission grid and distribution grid in certain parts of the US. The thing is that they're supposed to maintain the reliability of their section of the grid. To do that, they have monitoring capabilities, they need communication networks. That's where you end up with Ethernet-based networks, mostly fiber, to avoid noise. And there's usually, it's typical SCADA because it's long distances. Substations are all throughout a residential area or a city or a town. So they need to know what's going on. When it comes to load balancing, that's usually from the generation sources in the transmission lines, because the transmission lines are where you're sending high power. And the distribution grids can take in power or turn it off or generate their own if they want. So, locally here, where I live here in Pennsylvania, I talked to a local utility, and they buy power via the transmission organization in the area. So they buy power via transmission line, but they also have their own diesel generators that they generate 7 megawatts of power locally. So they can kind of load balance based on what's going on with the transmission grid and what they're able to charge for the power that they generate locally. So it depends on the time of the day, maybe. If the transmission power is more expensive, maybe they run the natural gas generators to generate power, and then they load balance that way. It's not really an orchestrated system. It's more of a set of small entities that then they're all connected together, and they kind of manage the power distribution and the power transmission based on what they control.
Gotcha.
But so it's a little.
When you say they're connected together, that's the electrical transmission lines that is not over like Ethernet fiber, or is it both?
No. So they're not typically connected together via communication. They're connected together via the power. So there is some communications that occurs, based on, I'm going to buy power, I'm not going to buy power, but usually that's not done via Ethernet communications between substations. Right. That's done differently. Like they'll open a relay to disconnect part of the grid circuit, and then they'll wire in their generators to then put power into the system locally. So yeah, it really depends. But like I said, the power reliability is really on the operator of that part of the distribution grid or transmission.
Gotcha. So what, I guess, like, again, I'm not very familiar with the NERC SIP standard. What are maybe, I don't know, like 3 like biggest or critical like failure points of like a substation like system? Obviously, I'm assuming that it's again, it's not on the open internet, so it's probably not going to get ransomware, or maybe it will, but like what are the critical items that they would specify are important to protect against?
So, I mean, one of the biggest ones is physical security. Like I can't emphasize that enough, that physical security is a part of security. You can't let people who are unauthorized into a substation and all of a sudden can plug into a switch within a home, or plug into, a cabinet next to a transformer. That's probably one of the bigger ones. And every time that you go, it's interesting, because if you go to a utility that follows NERC regulations, they all do the same thing. You have to sign in a book anytime you come in. Anytime that you have to plug into a switch, you have to run a virus scan. They may give you a USB-based virus scan, or they may tell you, hey, I need a printout of your company's virus scan to ensure that you don't have any viruses or malware on your PC before you plug in. They have all of these standards that they have to follow for people that come into and out of their network or their protection systems to be audited. So physical security is always there. That's why you see barbed wire fences around every single substation, because they've got to protect. Sometimes there's even IP cameras. They'll put cameras in substations to ensure that they know exactly who is coming in into and out of, or if there's anybody around the substation doing some shady stuff. That would be one of the big ones. And then the second thing is they have something in those standards called the electronic security perimeter, which is basically your firewall. So they heavily emphasize that every critical asset in a bulk system, so they call it the bulk electric system, where they have these cyber asset groups. So a substation could be considered a cyber asset. That system needs to have a security perimeter around it. It needs to have some sort of firewall in place to limit inbound, outbound communications, to provide the ability to do remote access. When they do remote access, they usually require a protocol break or a jump host. So you don't directly connect into the network. You actually connect to a PC that is on a DMZ for the local system, that then you use that PC to access things inside of the environment, so that you don't have direct connection into the substation. You're just using something that they can control locally. So that's another big part of it. And then they have a whole thing on cybersecurity awareness and building an awareness program, and basically getting the employees to be very cyber aware and to be schooled in good cybersecurity practices. Because once again, one of the main ways ransomware gets into a network is because somebody clicks on an email link that they shouldn't have, right? So you always got to consider the human factor or the insider threat as somebody that clicks on something, picks up a USB drive in a parking lot, plugs it in when they shouldn't, and then that's how they get in. So you obviously have to have a program built up to teach your employees that, hey, you shouldn't pick up that USB drive and plug it into your company laptop. Or when you look at an email and it has some fishy things about it, you shouldn't click that link unless you know exactly who that person is that's sending you that. So those are probably the three main things that kind of come off the top of my head.
Definitely makes sense. Dave, what are your thoughts on that?
Absolutely. So I think NERC SIP is interesting. Right. So I think it's interesting. I will be excited to have this conversation with you, Grant, probably next year around this same time, to ask how kind of the next 12 months of NERC SIP has been. I do want to ask one last question on the energy sector, right? So you talked at least once or twice about hardened equipment, right? Can you tell us what hardening means for the energy sector and how it's different than what we see in most OT areas, please?
Yeah. So hardening, I mean, there's a couple of ways you can look at it. Hardening from a physical and environmental perspective, a lot of what we see is the 61850 standard that I mentioned. There's a part in that standard called Part 3. So we call it 61850-3. That part of the standard calls out hardening requirements for substation-based devices. The whole point of it was that previously, 20, 30 years ago, there was a standard written for protection devices in a substation. So the protective relays, the breakers, the IEDs that are inside the substation, they wanted those things to be bulletproof because they didn't want weather, they didn't want temperature, they didn't want shock and vibration, they didn't want any of that knocking down a protection device that could prevent a power outage. So, several years ago when the 61850 standard was being developed, they decided to pull in the same requirements that they would have for the protection devices for the network switches that are in the substation in that environment. So you're talking, a lot of the manufacturers, if you look at the standard, it's plus 70 degrees Celsius to negative 40 degrees Celsius. A lot of manufacturers, including us, we're up to 85 degrees Celsius, which is like 160 degrees Fahrenheit. You have to follow some of the most stringent short circuit testing tests. You have to do some of the highest EMI noise resistance tests. You have to do the wide temperature shock and vibration to ensure that if, because when those relays and breakers open and close on the substation, it causes a lot of vibration because they're huge. So you can't have the switch when you open a breaker or open a relay, all of a sudden. So you have to meet the standards for shock and vibration, and you have to have 0 packet loss through those tests. So as you crank that temperature up to 150, you can't have a packet be lost through the switch. So it is really probably the widest standard in terms of environmental requirements out there for a specific industry. So, obviously that means that the equipment for those industries or for electric power tends to be a little bit more expensive, but it's purpose built so that, hey, if the AC breaks in the control room at a substation, that switch is still going to work because I can't have the AC going out in the control room, stopping power to homes in a local neighborhood. So that's why it's so wide and so stringent.
No, awesome. I think that's very interesting, and I can see the look on Vlad's face. Vlad absolutely has a question, but first we have some people to thank, and if everyone gives me a sec, because I actually have a picture as opposed to a video to share while I go through this. I'm clicking a whole bunch of buttons I didn't before this intend to have to do. Here we go. Boom. I think you guys can see the MGuard picture. I can see the MGuard picture. And having said that, we want to thank Phoenix Contact once again for sponsoring Cybersecurity Month. The mainstays of Phoenix Contact MGuard product family, models 2100 and 4300, get major upgrades now with gigabyte speeds. The flexible devices provide an accessible path for segmented and securing your industrial networks. The firewall, VPN, and NAT features ensure all your networking needs are met. Products are in stock and certified along with IEC 62443-4-1, and I feel every year Phoenix Contact puts an IEC number on there, and I butcher it every time, so thank you guys for that. The Phoenix Contact cybersecurity team also has a major upgrade announcement. They offer IEC 62443-2-4 certified services. These services include asset documentation, secure network architecture, as well as consultative advice on best practices for your systems. And again, we want to thank Phoenix for sponsoring this. This is their 100th year anniversary celebration, which is absolutely crazy. Thank you guys to Phoenix for sponsoring this and for being awesome sponsors of the community as a whole. Okay. Perfect. And we have made it back. And Grant, I don't know how much work you do with the MGuard product family as a whole, but Vlad and I, every time we get on, and I think we had this conversation with you last year, are always interested about the MGuard. Can you kind of maybe tell everyone who isn't in OT cybersecurity or network guru such as yourself, kind of what maybe some of these upgrades mean and what that looks like moving forward?
Yeah, so the new version of the MGuard is really designed to get better throughput on the firewall. So the previous iterations of the MGuard platform were 100 megabit connectivity, which nowadays with more data being moved through OT networks, the whole explosion of IoT devices and being able to do condition monitoring, you need bigger pipes for communication. So we're seeing a lot more gigabit and 10 gigabit connectivity in industrial environments. So this next iteration of the MGuard is really designed for that gigabit throughput and distributed to the edge of the network. So that's where the MGuard's strength is. It's general mount, it's a very small form factor. It really fits well inside a machine cabinet. So be able to provide protection at the machine level instead of putting it way up in your IT infrastructure or your OT infrastructure in the control room. You can put a segmented firewall right down at the machine level so that you can have some sort of protection right in front of your machine. So, in those cases, like I mentioned, with the Windows machines that are XP or Windows 7 that are unpatched and vulnerable, you can put an MGuard in front of it, and you can put firewall rules to prevent communication like SMB protocol from getting to that system. Only allow the protocols that you need to communicate to the PC-based system within the machine. So that's really where the value is for the product.
Grant, I'm hearing that I no longer need to update any of those Windows machines. Is that a correct?
That's what I heard.
Is that the takeaway?
I would say there's always a path to least resistance, right?
I was gonna make a brief comment, Grant, like on the point I think that was very critical you made before the ad read. And I think that, on the substation side, it is very regulated, therefore you need the resiliency and I guess the ratings of the switch. But
Hmm.
again, like I have many conversations with customers in manufacturing where I think it's a bit less regulated, right? There's not a prescribed, let's say, level of device. And that doesn't need to be like a networking device. It could also be something as simple as a power supply, but my like
Hmm.
discussion was around the same point, which is not all devices are made equal. And so if you pay extra, usually it's because, it's rated better, it's going to give you less harmonics on your lines, it's going to last longer, it's going to
Hmm.
withstand heat. And so I think it's an important point to sort of like drive on, even though it's not regulated and you can probably buy, the cheapest device there is on the market. There's a reason to pay like extra to have, again, like all kinds of different features, including like more resiliency of the device itself. And so I think it's like you said it really well, but I want to make sure that people understand it's not just the switches and just in mandated industries. I think in manufacturing we see that same range, but we don't
Hmm.
have as much of a regulatory body that governs stuff.
Yeah, and I will say there's no regulation that says the utility can't. The regulations for the security side of it, and there's no regulation that says that they have to use this 61850-3 hardware. But the industry as a whole has just grabbed onto that standard and said, "This is what we want because we don't want anything going down in a critical situation." And with manufacturing, just the nature of the industry is just slightly different. I mean, obviously, you're trying to cut costs in operations to try to most efficiently make a product.
Mhm.
So sometimes the cost consideration is a little more, stringent.
Mhm.
They want to make sure that they can produce something at the lowest price. So I think that's where it's up to the manufacturer on what they want resilience wise. Do they want a component that's going to exist in 85 degrees Celsius and have no packet loss? I mean, if they're confident that the facility that they're in is never going to be 105 degrees Fahrenheit or 150 degrees Fahrenheit, I'm sorry, then okay. You don't have to necessarily buy that kind of component, but you just need to be cognizant that you get what you pay for with industrial hardware. So
Absolutely.
for
I
sure.
think it's a very important point. I think it certainly resonates again, like in the conversations that I've been having. And again, I think it's always evaluating what your situation is and buying the right equipment. And I think, like I said, it's
Mhm.
like with electrical and networking gear, it's a bit less understood unless you talk to experts, right? And so you've been in the field, you know what it's like, but ultimately when you talk to someone who doesn't understand those differences, it could be difficult. But in any case, I want to move on. We had a good question from Zach. So this is going back to our conversation pre, I want to say, even the substation side. So he's
Yeah.
asking, is there an opportunity for AI monitoring with cybersecurity to prevent or identify a deep attack on critical systems?
Yes, absolutely. And I will say, AI is a tool that's already being used by a lot of cybersecurity vendors. And they may not advertise it as AI, but a lot of what it is pattern recognition, which is some sort of AI, right?
Mhm.
They A lot of the solutions. So typically, you have a set of what we call security controls. There's firewalls. There's intrusion detection, intrusion prevention systems. There's asset monitoring systems. There's patch management systems. The part where you're actively doing maybe AI analytics is on that intrusion detection system, the IDS. And a lot of what they do on the intrusion detection is they have patterns or what they call indicators of compromise that are known attacks or known threats that are out there doing this actively in other networks that they then feed in and say, hey, if you see this, this, and this, it's probably an attack. And it's a lot of pattern recognition. So they code in, here are the different things that go into it. If you see a spike in this kind of traffic all of a sudden over this period of time, and then it's followed by these types of traffic, that's probably a security event that needs looked at. So that's a lot of AI pattern recognition.
Mhm.
I think the opportunity to expand AI is only going to get bigger in cybersecurity because the, the attacks get more complicated. We have more connected systems, and the number of people that we have isn't ramping up to meet that same increase in complexity. And we're out here, and I'll champion this probably at the end of the meeting, that we need people to get involved and who are interested in cybersecurity to start pursuing it as a career path, but to fill in some of those gaps and to provide a resource to people protecting infrastructure. AI is an option. I would say it's not the one that you want to say, I'm going to put AI out there and it's going to solve all my problems. I wouldn't say that. You still need to have experienced professionals who know how to respond and deal with these events, and also notice when things are looking strange on a network. Couple that with AI to help augment their capabilities, and that will be the best formula that you have. So absolutely, there is definitely an opportunity for AI to help with cybersecurity.
I would also, like be curious again, maybe with on the other side, right? Like if attackers are using, I want to say like more clever messaging for those like ransomware emails, if they're trying to maybe like attack in different ways, like do you see like an increase of like attacks? Do you see an increase of maybe like breaches? Like are you seeing the red team, so to speak, use more like better tools, more advanced tools? Like how do you see like the evolution of those going?
Yeah, I think the attacks are always going to get more complex. There's always going to be a way to get into a system, and this is something that I'll preach here is it's not if it's going to happen, it's when it's going to happen, and be prepared when it does happen. That's the big key. I don't like to say doom and gloom. Cybersecurity obviously comes along with doom and gloom. It's mostly just awareness and trying to make people understand, like, these are real things that can happen. This can happen to your business. It can affect your operations and it can affect your bottom line, and you need to be aware and prepared for that. When it comes to the attacks, I think when it comes to ransomware, they're going to do the easiest thing that they can do, and they're going to cast a wide net. So the ones that are the most scary are you have phishing campaigns. So they send out a bunch of emails to a whole bunch of people, and then somebody's going to click the link. If they get one person to click the link, then they've won. It's all a money-making business. They want to put the least amount of effort to make the most amount of money. That's the whole point of ransom. What is more sort of concerning is a spear phishing campaign, which is emails crafted directly to specific individuals or specific companies, that there was some intelligence done to know how to craft that message. And I mean, we deal with it at Phoenix sometimes, where we've had emails that look like they come from our president Jack, and IT sends out a message, hey, if you see these messages, this is not from Jack. This is a spear phishing campaign. You'll get them. It wasn't super complex. I mean, somebody probably just went on LinkedIn and knew Jack was our president, but that's the more scary one, where somebody is specifically looking at your company and the people that you have working there, and trying to build a message that is specifically designed to get you. That's where it can get kind of scary. When it comes to like embedded devices and PLCs, and maybe something outside of ransomware, where they're actively developing tools to hack industrial devices. I mean, the world is a possibility. I mean, the problem with industrial devices is they haven't been built securely for the last 20 years. I mean, PLCs, embedded PCs, protocol gateways, serial to Ethernet converters, these were never, for the last 20 years, hadn't been designed with security in mind. So they're very vulnerable devices. The transition now, and one of the things we do at Phoenix, is we're trying to build secure products now for the industrial environment to help prevent more of these very sophisticated attacks from happening. So that's the big transition. So if you're looking for a vendor out there, always consider security when you're procuring hardware. Does the vendor take security seriously? Do they publish that they follow 62443, which is the security standard? Do they have a hardening guideline, how to configure the product for the best security for an application? Those are important things to consider when securing hardware.
Yeah, and it's very interesting. Like again, I don't certainly like have the answer to where it's going to be, how to say, like where the critical or the inflection point is going to be. But ultimately, I feel like we're like I recommend certainly putting the devices that can be plugged into a network on the network, so that again you get the ultimately the features, the data to be able to like access it remotely. And so ultimately, I think we're putting devices faster than we're able to protect, and ultimately as you like described, we have the limitation of I can't go and update every, let's say, like patch of the OS because I cannot stop the line. But ultimately, maybe
Mhm.
there's going to be ways to update that, like schedule that during like downtimes, and then it automatic. You know what I mean? There's like some kind of an again like orchestration engine in the facility that handles that in a way that is not intrusive. I don't know. Like I think there's going to be tools that will have to manage that somehow like automatically and not intrusively to manufacturing. But it's going to be interesting to see. I certainly don't know where. I think it's going to be on one side. There's going to be so many attacks that we're going to have to like stop doing what we're doing and sort of create a better barrier, or we're going to be able to secure it at a fast enough pace to prevent it. So it's going to be interesting to see.
Yeah, and I totally agree. I think the responsibility of vendors is to, once again, raise the floor on security.
Mm-hmm.
Make secure by design device. Design the device to be secure. If you do that, then you're going to prevent a lot of that low-hanging fruit type activity where they're just trying to decrypt the device that's easiest to get to, and you can prevent some of those attacks and reduce some of that fatigue that you might be mentioning with so many attacks coming in and so many things that we got to address. So that's really the vendor's responsibility.
Gotcha. Dave, what are your
Uh,
thoughts?
I really like what you were saying. What you're saying there, Grant. I guess let me ask you a question, right? And I think most conversations we have, and I think most of the groups that I know that I talk about, at the end of the day, everyone is very worried of someone clicking a link on the IT side of the organization, be it, someone who should know better that clicks it accidentally, or someone that opens, the hello at email address and basically clicks every single link because that's kind of just what their job is. And so I think that we certainly read about the vast majority of manufacturing or industrial organizations that run into problems because of that. What would you say to someone who's like, hey, we need to go focus on the IT side? Our OT technology is, in fact, so old, no one would know what to do with it, even if they could get onto our networks.
I mean, to be honest with you, I would say if you don't have a proper security program on the IT side, you need to start there and then worry about OT, because the vast majority of attacks are going to start in IT and then make their way into OT. So make sure that there's an IT security program, and a solid one that has a foundation for then your OT security program. To the point that, our devices are so old, nobody's going to know how to hack them. Believe me, there's always something. There's always a vulnerability in a system that you didn't know existed. Somebody plugs in a USB drive on a PC that might be ancient, running Windows NT, and then all of a sudden that system's compromised. There's always something, and I would say always consider that there is something. Don't just ignore it because you think that it might be so old that nobody's gonna know what to do with it. Believe me, there's somebody out there that knows that system and knows how to compromise it. The one thing I would say to the old systems is, even if you're not concerned, or maybe it doesn't have Ethernet interfaces, maybe it uses serial protocols, but at some point there's a data collection point so that you know what's going on in the network. You're going to have some transition from a legacy system to a new system. Everybody's got to do it. Business operations are evolving. You might have an ERP or an MES system that's now on the IT environment that you've got to collect some information about what you're producing, right? So there's some transitional interface. There's some gateway. There's some protocol converter that's getting it onto Ethernet. know it's there, know where it is, and then know how to protect it. The other part being, and I wanted to hit on this point at some point, is if there is an attack, know how to respond. Know how to clean the systems, have a plan in place, practice the plan, understand if you can operate manually, try to operate manually. Have controls in place or backups in place so that if there's a Windows-based system that that manages some part of your production facility, that if that system is compromised, you have a way to go in and go directly to the PLC somehow and off the machine or have some physical-based controls that you can operate with. So, using the excuse that, hey, it's too old, it'll never be attacked, I think is sort of a misnomer. It's something that people who don't want to deal with the problem kind of use to kind of say, hey, I'm just going to push it off. But then, when production goes down and you haven't done anything, the finger is going to get pointed at you. So that's what I would say.
Absolutely. No, I agree. And I think that you brought up a really good point, right? So cybersecurity, while we spend most of our time in the month of October talking very much kind of OT focused, it very much has to be looked at holistically. And I would say most of the IT people that I know are much more focused on security and cybersecurity than the OT people, of which, I don't know, probably 20 or 30% of them will go talk about a secret Windows XP laptop that we've got hidden from the IT folks on the plant floor. And man, we could not run if someone got to our secret laptop on the plant floor. But no, awesome. Thank you so much, Grant. So as our longtime listeners know, people know that I like to go ask for a future prediction of which I will do in just a moment. And I was going back and listening to episodes 82 with Grant to go listen to what his future prediction was. And I feel like both Grant and Vlad stole my thunder talking about how Grant predicting a bunch of ransomware and other attacks. And 9.5 minutes in, Grant described the entire last 12 months as the year of ransomware. So Grant, I guess maybe if we can have two predictions, one, so I can say that it wasn't as terrifying as last year. Can we have a slightly positive prediction of what you think is going to happen into the future? And then maybe a more broad or realistic prediction of what you think is going to happen in the future, please?
Yeah, for sure. I would say the positive prediction is that I think regulation is going to become more common. And it's already started to trend that way. So, we talk about NERC-CIP, which is regulation for the power industry. After the Colonial Pipeline incident that I mentioned and talked about last time, we now have TSA security requirements. The Transportation Administration now requires certain cybersecurity controls be in place for transportation-based industries, which pipelines are a part of, so that we don't have another Colonial Pipeline incident. So they now are trying to put in regulations to regulate that part of the industry. In Europe, they now have their Cybersecurity Resiliency Act, which is one that at Phoenix we're aware of because it's going to require us as a vendor to build secure products. So we're putting the measures in place to be able to document and then provide that documentation to regulators to say, hey, we are producing secure products. So that's already started. I think that that's going to continue. I would hope that we start having some uniformity to the standards and regulations that come out. I think they all kind of tie to each other in some form or fashion. The verbiage might be slightly different, but there should be some unifying jargon and terminology used across all of these regulations, and then try to target some of the same things. We just had a whole podcast talk about the difference between electric power and manufacturing. Obviously, those standards, the requirements and regulations might be different in both industries, but a lot of things will be common. So find the common ground and then identify the differences that might be in each one. So that is the positive one, in my opinion, is I think with regulation, it's going to help prevent some of these attacks and raise the floor, again, to say, on cybersecurity. I don't want to say doom and gloom, and I'm not surprised because saying ransomware is going to increase is sort of like, a softball. Yeah, that's going to happen. But, I think cyber attacks they're always going to be there. They're always going to be present. digital systems have vulnerabilities because you can't build a system that doesn't have bugs. If you find a product that doesn't have a bug, tell me, because I'll put it on a wall in a glass case and say, I found the missing link. So there's always going to be vulnerabilities in systems. We just need to consider that and know and accept the fact that that is a reality, and we need to know how to protect it, and then we need to know how to respond if there's an incident. So there will always be cyber attacks. I would say that's my grim prediction is next year, we'll probably be talking about more ransomware attacks, maybe some sophisticated OT-based attacks that somebody's uncovered. So there will be no shortage of attacks over the last year that we can talk about, which is great and not great.
Thank you for that, Grant. I feel like you very much hit that on the nail. Awesome. I guess second up, we would like to ask for some career advice. Lots of time we ask for people looking to kind of get into, in this case, cybersecurity. You talked about some certifications. We certainly need more cybersecurity professionals who understand industry. So from your perspective, if someone is interested, what are good steps forward?
Yeah. So I would say if you have an OT engineering background, if you're double E, if you work for power systems, if you work for control systems, you have some of the most valuable experience for being an OT security practitioner. So I would say it's great when an IT professional wants to get involved in OT and they come down and they want to understand these systems. That's great. Be open to it. Like if you're an OT engineer right now, which I know a lot of the audience is in the manufacturing industry, and you now have an OT security professional, or you have IT coming and telling you, hey, we need to secure these systems, work with them. They're there to help make sure that your job is easier if this ever happens. So I would say as a career advice, if you are in the OT engineering side, a manufacturing engineer, a controls engineer, and you see cybersecurity as a career path you want to take, I encourage you to take it. We need people who have had experience building these systems, designing these systems, programming these systems, because that's where you have an understanding of how they operate and the best way to secure them. So as somebody that started in the controls environment, that's been invaluable for me because I know how a PLC-based system works. I know how to program an IEC 61131. I know what ladder is. I know what function block is. I know what Profinet is and Ethernet IP. These protocols are different than your standard web-based stuff. Mm-hmm. There's sensitivity to it. Heck, Ethernet IP. I can't tell you how many times we talk about multicast clogging up the network and needing to turn an explicit messaging to implicit messaging, or vice versa. So having that experience is invaluable as a security professional. So if you are thinking about it, pursue it. There's plenty of resources out there to get started. I would start with maybe a CCNA course, maybe a basic networking course. A lot of universities, local, have some sort of basic networking course that you can take. There's websites out there like Coursera or Udemy that offer very low-cost networking classes to learn a little bit. You may have some cybersecurity stuff. Those are really great starter resources. When we have new employees at Phoenix that say, oh, I'm interested in networking cybersecurity, I usually point them to Udemy. Mm-hmm. Say, hey, there's a $15 networking course that will teach you about the OSI model. Start there and learn a little bit about that. And then, as you progress and maybe you talk to your management and say you want to do this as a full-time gig, go out and research some of these industry certifications, Security Plus, Network Plus, and CompTIA, CCNA certifications are a good basis. The SANS organization, like I mentioned, has great certifications. Those typically are on the higher side for cost. You can find lower cost options out there as well. A CISSP, which you guys mentioned, is a good one for managers who might be dealing with security. That's more of an IT-based certification, but it's a good one to kind of build that base level understanding of security and then build off of. It's a very rigorous exam, by the way. So not for the faint of heart. But so that would be my career advice to go about there.
No, fantastic. I think that is some great advice. We'd like to ask for a book recommendation. It could be either very industry specific or something else that you enjoy reading, depending upon whichever way you'd like to go.
Okay, so I got 3, and it kind of goes along with some of the things we talked about. So if you're wanting to get more into power systems and the digitization of the electric grid, I highly recommend a book called IEC 62850, Digitizing the Electric Power Grid by a gentleman by the name of Alexander Apostolov. It is a great resource to understand that digital transformation in electric power. It can get very technical, but it's also got some high-level parts that are a little bit easier to digest. But it's a great read, and it was one of the ones that I used to kind of get a little bit familiar with the details of the protocols and things like that. The other one that I would recommend is Guideline for Industrial Security, IEC 62443 is Easy, by a gentleman called Pierre Combs. I'm sorry. That was, if you're ever trying to get into security standards, 62443 is one of the key ones.
Okay.
It was a guide that I used to help me get a little bit familiar with it, because the standard is massive and there's a lot of different parts to it. So that book kind of brings it all together and organizes it for you and kind of explains why the certain sections are written the way they are. And then the last one, and this is a personal one, I don't know if you guys have ever watched the TV series The Expanse on Amazon. It's a sci-fi series. It takes place in space. I watched the series, loved the series, started reading the books. The books are amazing. So highly recommend The Expanse series if you've ever heard of the show, or if you want to try new sci-fi series.
I have watched the show. I've enjoyed the show. I've heard positive things about the books. I have seen the Kickstarter, but did not back the Kickstarter for the next series of books that you could also go buy, all of like the super embossed versions of them. So I would absolutely agree on all of the series that I have enjoyed. Thank you so much for that, Grant. And then the last question is who should reach out? How can our listeners help you? Is Phoenix looking to hire in your department? Are you guys looking to have interesting conversations kind of in open forum for you guys?
Yeah, by all means, if you want to talk cybersecurity, if you have questions about cybersecurity, feel free to reach out to me. If you're in the electric utility industry and you want to talk about digital substations, I have a lot of experience with 62850. We can talk about that. What are some of the challenges? What are some of the benefits to it? In general, if you want some career advice on trying to pursue a career in OT cybersecurity, feel free to reach out. I'm pretty regular on LinkedIn, so that was probably the best way to reach out to me. Just shoot me a DM and we can chat. So that's good to can reach out.
Awesome. I appreciate it. Thank you so much, Grant. Thank you, everyone, for coming to hang out. Again, if we didn't get to your questions, we will go back to get to them. If you guys are not following Grant, the vast majority of our listeners are on LinkedIn. Please head over to the Invent page on LinkedIn. You'll see Grant going and tied to that. While you're doing that, make sure to follow Phoenix Contact USA for their 100th anniversary, as well as Manufacturing Hub and Vlad and myself. If you guys have made it this far in podcast form or are watching on YouTube or somewhere else, please hit the like button. Please rate us 5 stars and like and share everywhere you can do that. I have heard and learned that if I ask you guys continue to do that, and the listeners and watchers continue to trend in the upward momentum. Until next week, we'll talk to everyone soon. Thank you. Bye-bye.
Thank you, everyone.